Okay, we are back. And thanks for those of you who are staying. Just hope you're enjoying this ride. I know it's a little complicated, but once you get the hang of it, you can work it out. Okay, let's look at the next section here. So the next section essentially is finding the Ka of an unknown acid. Trust me, method number one, we have done already in class. But as I mentioned, I think at the time I told you that there are other methods for finding the Ka, and this is what we're going to discuss, right? So method number one says a 0.2 molar solution of HX, let's call it acid HX, has a pH of 2.11. What is the Ka of the acid? So we've done this before, right? So let's go ahead and solve it here. All right. I'm going to bring another piece of paper here. This is going to be method number one. All right, method number one. Whoops, sorry. Method number one. Now let me do this. Let me pull out a little bit again. Here we go. All right, so let's talk about our acid. We're going to call it HX. And what we know as a weak acid, it will ionize into hydrogen and X ions. All right. We are told that it's a 0.200 molar solution. So again, we're going to set up our ice. 0.2 molar. We're going to have a change here. And like always, I like to use the Y instead of X. And so at equilibrium, you will get 0.200 minus Y, Y, and Y. Now, the thing here is that we know that Y is the concentration of hydrogen ions, right? So that means that we can say, well, that'd be 10 to the negative of the pH. In other words, 10 to the negative of 2.11, right? Okay, this is where I had to get my calculator out. Say hello to my little friend. Here we go. Okay, so 2.11 negative, and I'm gonna get, in my calculator, there's a button here for 10 to the whatever that is. And this comes out to be 7.76 times 10 to the negative 3, I believe. Let me zoom a little bit there. Here you go. Times 10 to the negative 3, right? So let's say 7.8 times 10 to the minus 3. Because this is 2 decimals, that means it should have 2 sig figs. So essentially that is the molarity of hydrogen ions in here. So Ka should be hydrogen ions times X minus divided by HX, and that should be Y squared over 0.200 minus Y. And you are on your own. I'm going to leave it there. You guys can finish it from there, right? You're going to find out what Ka is based on this experiment. So we've done this before in class. You don't remember, but trust me, you were there. We did this before, all right? So this was the method that we studied in class for finding the Ka of a weak acid. Just have a solution of a known molarity and measure what is the pH of that solution. And from there, you can get what the Ka is. Okay? Let me know if there's any questions. I'm not going to do the rest of the problem for you. You can do that yourself. All right? Okay, let's look at method number 2. All right, it says here, whoops, sorry. forget that this thing has a little bit of a lag time. Gotta do it a little slow. Okay, now you have a 0.2 molar solution of the salt of the acid, sodium, whatever that thing is. And we have the pH of the salt solution. So what is the Ka? Now notice the hint is that you set up an ice table, but you have to be careful not to confuse Ka with Kb. Right? Remember that we said that the salt solutions of a weak acid give us hydrolysis, right? They basically affect the pH, unlike, let's say, sodium chloride or someone. So this is method number 2. So what we're saying here is that this salt will react with water to give us back the acid plus hydroxide ions, right? Once more, we're going to start here with a solution that is 0.200 molar. We're going to see a change now because this is a base. Again, I use a different letter, and I might, in a year or so, I might change these letters. I'm going to use Z here for that one. And so at the end, we're going to get 0.200 minus Z, Z, and Z. So we have our ice table. Remember what it said there. Don't confuse Ka with Kb. All right. Careful. We can find Kb from this because it would be the product of the conjugate acid times the hydroxide ion concentration divided by the molarity of the base. But remember, this here, Z, is the molarity of hydroxide ions. How do I get that? Well, the only piece of data I have is the pH of this solution, right? We said, or no, we said, they told us, sorry, that the pH is 8.56. So that should be 14 minus the pOH, right? So that means that the pOH would be 14 minus 8.56. What is that? 5.44. And therefore, the hydroxide ion concentration will be 10 to the negative 5.44. So that's 3.6 times 10 to the negative 6 molar. I hope I didn't go too fast. I'm assuming by now you're kind of pretty well versed in doing these ice tables and stuff, right? Okay, so there we go. 3.6 times 10 to the negative 6 molar. That's the concentration of hydroxide, but we said that's Z here. So basically, we can calculate Kb as, Z squared over 0.200 minus Z, and you guys can do that. But that was not the thing they asked us for. They asked us for Ka of the acid HX. How do we get that? Well, remember that Ka is Kb, I'm sorry, Kw over Kb. So again, the pH allows us to calculate the hydroxide ion concentration, which based on the ice table allows us to calculate a Kb constant. And then from there, we can calculate what is the value of the, oh, there you go. It's a little better there. You can see the whole thing. You can get the value of Ka from there. So that's method number 2. So method 1, a solution of a known concentration of the acid, and you measure its pH. Method number 2, a solution of known concentration of the conjugate base of the acid, or the salt of the acid, and you measure its pH. So two pieces of data, the molarity and the pH. All right, let me see if you have any questions. Again, I'm not going to finish the math here. You guys can finish that, right? Okay. A few more seconds, and then we'll do method 3. All right, let's see what method 3 is. Here is method 3. So here's an interesting one. You have now a solution that has both the acid and the salt at equal concentrations of 0.200 molar. And once more, you measure the pH of that. What is the Ka of the acid? And they give you a hint. Use the Henderson-Hasselbalch equation. Okay, ready? So this is now going to be method number 3. So bring it over here. Make it so big there. All right, so it says here to use the Henderson-Hasselbalch equation, which is pH equals pKa plus the log of base molarity over the acid molarity. And we're being told that this solution has a pH of 4.11. But more importantly, it tells us that the concentration of the base equals the concentration of the acid. So therefore, the log of this ratio, if they are the same, equals what? What's the log of 1? That's right, 0. Therefore, the pH equals the pKa. And so the Ka is going to be 10 to the minus the pH. So here's another method. If you are able to make a solution that has equimolar amounts or concentrations of the acid and its salt, and you can measure the pH of that solution, it gives you the pK from where you can get essentially the Ka of the for the acid. So one of the things will be is as you go through these exercises, in the end, you'll have to kind of like figure out of all the 4 methods, what is the average you get, and how close are they to each other. My experience has been that typically this method has a tendency to kind of like slightly overestimate the Ka. I actually did this experiment one time for a class at CHEM in Cypress College, where the students actually had to do this exercise, like make the solution and measure the pH. I think a lot of it's kind of difficult to really get the exact molarity sometimes. And so there's a tendency typically to overestimate the Ka value here. Anyway, so that's that one there. Cool, any questions? Okay, now we come to the big one here. Okay, so our next question is, let it focus, focus, focus. Ay, ay, ay. Notice that the first 3 exercises required that you be able to prepare solutions of known molarity. In other words, it's kind of like the formula of the acid. And so you're able to calculate enough to make solutions of specific molarities. But what if you can't? What if the acid is such an unknown that you don't even know its formula, and so you don't even know how to make a solution of known molarity? All you know that it's an acid. You know it's an acid because like it turns, blue litmus paper pink, maybe, whatever, or because a solution of it has a low pH. You know it's an acid because of that. But you don't have a way of knowing its actual molarity. So what you do is you do a titration. Remember, the major objective of titration is to find the concentration, the molarity of this particular acid. So we do that, but what we do is that instead of doing a indicator-based titration, we do a pH titration. We do a curve, and they're going to give you the data back here, all right? Now, the cool thing about pH titrations is that actually, if you have the equipment, they sell these probes that attach to your computer, and you basically dip the probe into your solution with a stir bar, and you start adding the base, and the program essentially tracks the pH and draws the graph for you. Man, I wish we had one of those. It's pretty cool. We used to have them at Saddleback College. But in this case, what you did was you added success months as 1, 2, 3, 4, 5, 6. You're basically going one by one here, and you're measuring the pH after the addition of each amount of NaOH. And now what you have to do is you have to do a graph with this data. All right, you have to do a graph with this data, and there's going to be several things that are going to be. So let's go through the steps here, so we know what we're going to do, and then I'm going to walk you through it on the on my Excel program here. All right. Okay. So it's kind of a little blurry here. You're going to make a plot of pH versus the milliliters of NaOH. Don't forget, the NaOH is standardized. Okay. They're going to give us the data of what is the molarity of it. And when you use Excel, again, use the format that's called a scatter plot with smooth lines. It's the same one that we did for the buffer experiment, the pH experiment on Tuesday. And then you're going to draw, I showed you how to do this in our lecture on Tuesday, but you're going to draw a horizontal line across the flat sections at the top and another one at the bottom. And you're going to find what is the halfway point between the two sections and where does it cross the line, so you can find what is the X value for that pH, and that's going to be the equivalence point of the titration. So from the equivalence point, you can essentially calculate what was the molarity of the acid. All right, so you should be able to do that. Remember, equivalence point is the point at which all the acid is neutralized. So all you want to do is find out, okay, how many milliliters of NaOH were added when I got to the half point of that rising part of the curve. Now, what they're going to do is they're going to ask you, well, find out how many milliliters of NaOH did it take to get halfway to the equivalence point. This is where half of the acid is neutralized. Okay, I'm going to come back to this in a moment, but let me walk you through the graph again, so we can see. I'm going to go here. Hopefully I have it up here somewhere. Where is my Excel graph? Hold on. I think I forgot to load it. Sorry a second. Hold on a second. Okay, so we are going to set up this chart here. So I'm going to go back to Excel here. I have my Excel spreadsheet here. And what I did here was I copied the data. I put in here the, the volume of the unknown acid, the molarity of the NaOH, and then all of these different values in here. Okay, and I'm gonna block a few things here. Oops, sorry, not that one. I want to do this guy here, this guy there. Okay, I want to show you those things later on. Okay, so let me get this guy out of here. Okay, so we're gonna select all of our values here, and we're gonna use insert. We're gonna do a chart that is the scatter with smooth lines, and we're gonna have to add our axis titles, but we need to edit all this. So I'm gonna call my graph, I'm gonna call it titration of unknown weak acid. The x-axis, of course, is gonna be the milliliters of NaOH. Our other axis title is going to be the pH. And now what I want to do is I want to make this a little bigger so we can see it much better, right? Let's make it a little bigger here. Okay, remember that we're tracking a curve here, so we don't look for any linear trends, so no trend lines in here. And the idea now was I want to find out what is the number of milliliters of NaOH to reach this halfway point here to the ascending part of this line. Remember that, as we said, the curve begins to rise and then it levels off because as the acid is getting neutralized, it produces its conjugate base, which hydrolyzes and forms a buffer. So they resist the pH change over a while until they just get overcome by the excess NaOH, and so they yield to it, and then the pH starts rising again. So one way you can do this, again, you can pretty much eyeball the middle point of the graph here. One way you can do it is you can put in lines here at the top and at the bottom and find the half point between them. So one of the things that we learned was that sometimes the shapes menu is not around, so I'm going to call it up here in the search. And I want to draw a line here. It's going to run across the top of the chart here, kind of like around where this thing levels off, right? And I don't like that actual color there, so I'm going to make it black here. And then I'm going to run another one like it. So I'm going to copy that. I'm going to paste it. And I'm going to run another line like that one over here in the bottom. And then what I'm going to do is I want to find out what is the half point between them. What is this point here? So what I can do is I can put in another of these lines, and I'm going to locate it right between them. So that's 4, that's 13. So 8.5 would be the half point. It'd be kind of around here. So I'm going to run one there. And then what I'm going to do is I'm going to find out that's the kind of the half point of us. And actually, you know what? This one is a little high. I'm going to put it a little lower here. Just a tad lower. There you go. All right. So I want to find out how many milliliters of NaOH did it take to get to this point here. So I'm going to run another line here. And then what I want to do is I want to change its color. So I'm going to format it here to make it red. And I'm also going to see if I can find where to rotate it. Here it is. So we're going to rotate it 90 degrees. And I'm going to bring it over here and find out where does the curve cross that horizontal line there. And that's a little too long there, so I'm going to make it a little shorter here. And there we go. Boom. Boom. Okay. So I'm doing all this just to find this spot here. In other words, I'm trying to find out what is the point at which the milliliters of NaOH took me to halfway on this ascending part of the graph. So when I come back here, I find out, okay, what was the pH there, right? We found out it's roughly about 8.50. which makes sense because we said for a weak acid, the equivalence point is not going to happen at pH 7. It'll be a slightly higher because of the back hydrolysis of the conjugate base. So we would say that at that pH, it took 15.40 milliliters approximately of NaOH. And so we can use that data to calculate, well, what was the molarity of the acid. And I'll let you guys do that for yourselves. Now, what the handout was telling us was, can we find the spot that is halfway to the equivalence point? And what is the pH in there? So we would say that essentially halfway to the equivalence point of 15.40 would be 7.70 milliliters, right? Which is somewhere in here. And we find out what is the pH over there. It's about almost 4, maybe a little less. The person here called it at 3.90, but I think if you guys say 4, that'd be perfectly fine. Now, why is that significant? Remember, at the equivalence point, all of the acid is neutralized. Halfway there, half of the acid is neutralized, which means you have half acid, half base. So according to the Henderson-Hasselbalch equation, the pH would be equal to the pKa plus the log of the molarity of the base divided by the molarity of the acid. But at this halfway point, where you have the same amount of acid and base, so if base equals the molarity of the acid, then at that point, the pH equals the pK. And of course, just like we did in the third method with the buffers, if you know the pH, then the Ka is going to be 10 to the minus the pH. And that's how you can do the rest of the exercise. Here I left it open for you guys to do it. But you might want to organize your graph this way. And, you know, like I said, technically what they ask you to do is to show the graph and upload the graph. You know what? If you want to upload the whole spreadsheet here, that's fine with me. If you want to do it this way, you don't have to do it that way. You can do it by hand, or you can do it in a document and basically, you know, copy and paste the chart into the Word document or whatever other kind of word processing format you have. Okay, so that's what I wanted to show, and I can come back here, and now at least we got that recorded. I'm sorry guys to keep you waiting here extra time, but okay, so let me see if there are any questions, either via chat or if you want to unmute your phone and ask anything else about this activity. It's almost 9 o'clock, so I'm going to sit around for another 10 minutes. If you have any questions, well, maybe a little bit longer. And while you guys work on it, and that way, if you have any questions, you can ask me. But I'll definitely be available via text or email or Canvas messaging till 10 o'clock. So if you have any questions before that, like I said, the goal was to turn it in tonight, just get it out of the way. So if you guys can do that tonight, that'd be perfect. Many of you did that on Tuesday, and I'm sure you had a better night's sleep and had to worry about it. But that's okay. If you can't finish it tonight, that's fine. Just turn it in later, okay? I just don't want you guys to let things accumulate so that suddenly you're swamped with all stuff. Remember, we have a lab that's coming up, and that's the KSP lab. Let me briefly go there to remind you of that. Where is our thing here? Okay, here's our Canvas page. So again, if we go to the assignments here, notice that you have several things here going on. You have your quiz, which you need to do by Sunday, and then experiment P12, which is a determination of KSP. So this is one of those where you have several steps in it. Okay. Again, we studied tonight KSP. You can either look over our lecture materials or read it in Top Hat text. Then in your lab manual, this experiment is in there. It's very well explained, but just in case, I put in here a Word document file of it. So if you guys need to see it, it's going to take a little while to load, so I'm not going to upload it. And then I give you here a review of the strategy. So read through that so you can find out what we're doing. So essentially what we're saying is that in this particular case, the compound, when it dissolves, it produces an ion that is an acid. And so if we titrate the acid in that saturated solution, we can find out the value of the concentration of it, the value of S, and we can go from there to calculate the KSP. All right. I did put a video here in case you forgot about how titrations are done and that kind of thing. So you will be given a data set. All right. It's a data set you'll be given. And basically, you will have to use your data set. So for example, let's say I go here to the grades. All right. And I'm going to locate that experiment, P12. Let's see, where is it? P12, here it is, P12. And there should be a message in there on the right side, the little dialog box there. And when I open it, it gives me a sample data set for me to download that I'm going to use to essentially answer the questions in the lab. It's essentially like a titration experiment, all right? That's essentially what it is. So going back here, we're going to go back to the assignment. And then notice that at the bottom, it tells you where you'll submit. There'll be a data set. The data table, you had to kind of like finish filling out calculations pages. Now you're doing 3 trials of a titration, so you only need to display 1 set of calculations. And there's also a post lab here. And the post lab is essentially another exercise that is parallel to what you did, just with a different compound. So they give you here the volumes, the titration, and then you do the same calculations you did for this experiment. I just want you to get some extra practice. So that'll be your post lab, okay? All of that is due by Sunday at midnight, and you'll be submitting everything via file upload, okay? So because you have to do this, I would really encourage you to finish up tonight's activity before midnight, upload it, turn it in, and get it over with so you can spend some of the weekend doing this, and you'll get the study guide for the test hopefully by tomorrow, so you can start lining up your study time and get ready for next week's exam. Okay, don't forget that on Tuesday, we're going to wrap up our study of Unit 16, the solubility equilibria, and then we'll have a review for the exam. I don't have anything scheduled for lab time on Tuesday. I don't think so, right? Or do we? Let me see if we did anything for there. Okay, let's see. What's our schedule? No, we don't have anything scheduled for Tuesday night. I just wanted to leave it kind of open for you guys to study and stuff. I don't want to take up your time. All right. So that's the plan. Okay, I'm going to stop the recording here, but I'm going to stick around in case you guys have any other questions. Okay. So that's going to be it for the recording.